All right, let's go. And I got to share my screen with you. Okay. All right. So here we're going to determine what the scale factor is, and then we're going to look at calculating the area of each one. Okay, so here, our actual, all right, so we're going to do, so remember the scale factor is the scale value. Let me write that down. All right, so the scale factor is our scale divided by the actual on there. Okay, so we're going to have two of these to look at. So for these two here, right, it's going to be 8/4, which means our scale factor would be 2. And then we can see that it's the same for the other dimension, right? If we were to check that, right, it's going to be 6/3, which would be 2. So 2 is our scale factor. All right, and then the actual area, right, is going to be 4 times 3, so it would be 12. And then the scale area is going to be 8 times 6, so that would be 48. All right, and then it wants the ratio of the scale drawing area, so 48 over the ratio over 12. So that ratio is going to be
would be 4.
Would be 4. All right. Okay, so all right, so now we're going to do, this is with a reduction in there, okay? So our scale factor, and let's just use this one here. So our scale factor is 2/6, which would be 1/3. Okay, and then our actual area is 6 times 9. So our actual area is 54, whereas the scale area is 2 times 3, which would be 6. So again, our ratio of the scale area to the actual area is 6/54, which would be 1/9, right? So we can just leave it as a fraction.
All right.
Okay.
Yeah, that makes sense.
Okay. All right. Oh.
Sorry, I was a little late.
Oh, okay, that's all right. Do you have the document for today's lesson?
What day is today?
Day 4. It's day 4.
Yeah.
I do not.
Okay, go ahead and pull that down.
Lessons?
Yes.
Okay, I do not have it. I have every other day, but not day 4.
It should be on your very top.
Let me make sure that I click. Yeah. I did assign it, so it's under assigned.
Oh, now it popped up. Thank you.
Okay.
Now it's the same thing as yesterday, just do it on paper?
Yeah, that's fine.
Okay.
Okay, so what we're doing here is we're looking at the scale factor, and today the focus is looking at how the area is affected by the scale factor. All right, so I can I'll talk you through this. So our scale factor, right, is the scale divided by the actual. And so in this first one, our scale is going to be 8/4, which would be 2. Okay. And then the actual area, we're just using these units. So the actual area was 4 times 3, which is 12. And then the area of the scale drawing is going to be 6 times 8, or 48. And then it wanted us to look at the ratio of the scale over the actual area. And so the ratio of the areas is 4. Okay. And then we did the same thing with this one down here, except this one, the actual is bigger than the scale. So we did our scale factor is 2/6 or 1/3. And our actual area is 6 by 9.
Is that one for today?
So 54. Oh, hey, I didn't see you come in, Macy. Yeah, this is the one for today.
Okay.
Day 4, yeah. All right, so our actual area, 6 times 9 is 54. And then the area for the scale is going to be 2 times 3, or 6. And then if I look at the ratio of the scale area to the actual, I get 6/54, which is 1/9. And so one thing to notice here, like look at our scale factor when we're looking at one dimension versus the scale factor when we're looking at the areas. And then the same thing here. There's our scale factor when we're just looking at one dimension, but then when we look at the area, okay, so do you see how the area, the ratio of the areas is the scale factor squared, right? So that is 2 squared, which 2 is our scale factor there. And then this is 1/3 squared. So to get the ratio of the areas, we can square the scale factor, and that'll tell us the scale area to the actual area. Okay. Whoops. Went too far. Hang on. Let's go back up here. Okay. So here, again, it wants us to do our scale factor. So I'm going to use the bottom. So 8/6, which, let's simplify that down. That's going to be 4/3, right? All right. And what's the area of a triangle?
Like the formula?
Yeah. Do you remember that?
It's isn't it like area equals like
it's base
something like base times
I'm
pi
pretty
over
sure
2 or
it's
something?
base time. I'm pretty sure it's base times with times half.
Yeah. 1/2 times the base times the height on there. Okay. So here for my actual area, I have 1/2 times 6 times 9. So that's, what is that? 27? Okay, and then our scale drawing area is going to be 1/2 times 8 times 12. So that's going to be 48. All right, and then the ratio of the scale, 48 to the actual 27. So that, what is that decimal value? 48 divided by 27. So I'm getting like 1.78. All right, and so let's test this out. So 4/3 is 1.33. So if I take 1.33 squared, is that the same? Yeah, it's approximately that. So that is approximately 1.33 squared. So that matches up too. All right. So, all right. It says, what do you notice about the ratio of the areas? Complete the statements below. All right. When the scale factor of the sides was 2, then the value of the areas was, the ratio of the areas was 2 squared, or 4. And when the value was 1/3, then the ratio of the areas was 1/3 square, or 1/9. And when it was 4/3, if I square that, what do I get? 16 over 9, which is the same thing as that simplifies to 16 over 9. Okay, so the key thing here is that the ratio of the areas, and that's scale area over actual area, that is equal to the scale factor squared. Okay, so far so good?
Yep.
Okay, all right. Okay. All right, so let's see. So we're back to this little basketball court that we talked about yesterday. All right, so get that mark off there. All right, based on your drawing below, what will the area of the planned half court be? All right, so our scale on here, it's 1 inch on the drawing corresponds to 15 feet of actual length. So
You would
want to
define the
do,
area. The 1 2/3 inches is 1.6 repeating.
okay, all right. I'll just round it there. All right, so the area of my scale drawing, that's going to equal 2 times 1.667. All right, so 2 times 1.667. So I get
3.3 repeating.
Okay. All right, and so if we look here, it says our scale is that 1 inch is 15 feet. Okay, and so so that's our scale factor on there. And then we're going to, which let's see if it's, all right, let's double check and make sure we're going to get the right answers too. So let's go back yesterday, right? We converted these, well, I'll do it up here first. So if it's 1 inch to 15 feet, then 1.667 inches is X feet. So let's see what that dimension is going to be. So I'm getting that the actual size for this dimension is about 25 feet. And then if I do the same thing with the 2, so 1 inch to 15 feet, and then I'll do the same thing for 2 inches over X. So that means that the actual size of this is going to be 30 feet. Okay, so
Mr. Billy's,
Uh-huh.
is it okay if we do it on paper, take a picture of it, and email it to you?
Yes, yes.
That's what I'm doing.
Okay. All right, so let's see how, all right, so if I were to do that multiplication, so I know my area is going to equal 30 feet times 25 feet, which is 30 times 25. Okay, so if I convert each side to feet to find out what the actual feet are, then I can get it that way, all right? But the other way I can do it is where I have, so I have my area of the scale drawing, and so I can multiply the scale drawing area times the scale factor squared on there. So if I do, all right, let me set up, it's a good way to do the ratio here. If I do all right, I'm going to go slide down just a little bit. All right, so if I'm working with areas, I say that 1 inch squared over 15 squared feet is equal to, and this is 3.34 inches squared over x. So I'm going to multiply, so x is going to be 3.34 times 15 squared. And it should come out to be close to what we did when we converted the sides and then got the area that way. So the two measurements should be very close. So 3.34 times 15 squared. Yeah, it gives me, it's a little off, but that's probably rounding. So it's giving me 751.5. So a little rounding difference there. Whoops. But, so that's two different ways that you can get the area of something based using the scale factor. You can either use the scale factor on each of the dimensions and then multiply, or you can take the area of the scale model and then square the scale factor. So either way, we get about the same answer. Okay, so where'd my mouse go? Oh, there it is. Okay, does the actual area you found reflect the results we found from 1 through 3? And that would be yes. Yes, because the area of the drawing, which is our scaled thing, times the scale factor squared is equal to our actual area. Okay. All right. Okay, so here, the triangle depicted by the drawing has an actual area of 36 square units. What is the scale of the drawing? Okay, and so here, like what we were doing, let me go back up to that from before. Okay, so the scale area over the actual area, okay, so that's our equation. The scale area over the actual area is equal to the scale factor squared. Okay, so here it's giving us the actual area. All right, so we're gonna fill in the actual area. It says is 36. So now we need to find the area of this drawing here. So I have 1, 2, 3, 4, 5, 6. So my base is 6 units, and my height is 3 units. Okay, so the area equals 1/2 base times the height. So 3 times, so it would be 9. Okay, so 9/36 is equal to, and I'm going to call this my x, all right, is equal to x squared. So let's see, 9/36 is 1/4, right? Or 0.25. All right. Now, have you guys had where you're solving something like this before? If instead of x, you have x squared?
Yes.
Okay, all right, so I'm going to solve it right. I'm going to take the square root of both sides, right? So that's going to take the x, get me my x by itself. And then if I do the square root of 0.25, I get 0.5. So our scale factor is 0.5. That's the answer it wants there. Okay. All right, what else they got for us? Okay. Oh, okay, now I've got to give you dimensions on this. Hang on, because we can't use a ruler. So let me find that problem.
Is the homework part coming up on this, or are we still just
Yeah.
practicing problems?
Right now, we're practicing problems. We'll get to the homework part here shortly. We're almost there. Okay, so let me give you the dimensions here if we were to measure these. Okay, so this one from there to there is 2.5 inches. And this dimension is 3/4. These are all, I'll just put these are all in inches. This one here is 1/4. The bathroom there is 1/2. Kitchen is 1/2. And that is 1 inch. This closet is 1/4. And the total from there to there is 2 inches. And then on the other apartment, that is 1/2. This is 3/4. This is 1/4. That length there is 2. This length there is 5/8. The whole thing here is 1.5. What else do we need? This closet. That's 1/4. Excuse me. By 1/2. And this distance here is 3/4. I think that's all the measurements they gave us. Okay, so here it wants us to, all right, find the scale drawing area for both apartments and then use it to find the actual area of both apartments. Okay, so the area over here, so the area is going to be 2 times 2 1/2. Wait, let me go down where I've got some more room. All right, which equals 2, that equals 5. Okay. And this one over here is 2 times 1.5, which would be 3 for that apartment. And then it says, use it to find the actual area of both apartments. Okay, so our scale is 1 inch to 12 feet. So we're back up to using this equation that we used up there, that the area of the drawing times the scale factor is equal to the actual area. Okay, so the area on my drawing is 5, and then times the scale factor. Hang on, is there a table under there? Oh, okay, doesn't have a table. All right, sorry, 5 times, and so this, for this one, it's 1 inch to 12 feet. So 12 squared. So that's going to be 5 times, oops, 5 times 12 squared. So I get, try that again, 720. So that's square feet would be that one. And so for this one over here, I have 3 times, and this one corresponds to 16 feet. So 3 times 16 squared, 3 times 16 squared, I get 768 feet squared. Okay, so one's a little bit bigger. Which apartment has closets with more square footage? Okay, so what have we got? A closet. It has 2 closets. So, all right, let's look at, for the suburban one. Okay. Suburban, the closet, we'll say closet 1 and closet 2 because it has 2 of them. So closet 1, I'll call this one 1, call that one 2. So it's a 1/4 inch by 1 inch for that dimension. So 0.25 from that one. And then the second closet, whoops, I just clicked the wrong thing. Go back. The second closet is going to be a 1/4 inch by, okay, so the whole thing, this whole thing is 2.5. And then to here, whoops, to here is 1. So that closet has to be 1.5. So we have 1/4 times 1.5. So that's going to be 0.375. So the total closet area in the suburban one is going to be 0.25 plus 0.375, or 0.4. Okay. And, oh, I did it again. Hang on. There we go. All right. So here, this one has 2 closets as well. All right. So I want you to figure out what's the total closet area in the city apartment. Grab a little sheet of paper. Okay, plus. All right. Okay, do we have an answer?
I'm still working.
Okay. So we're just doing the closet. So we have this one here and this one here. I need to preserve this, post this picture. Let's see. So I'm getting 0.3125. And that's going to be, well, that's in inches squared because I'm using the scale value. Is that what you guys got?
I just got finished with it. I got 1 decimal above you.
Okay.
I got 32.3225.
0.3255. All right. What about Macy? What'd you get?
I got 0.5.
Oh, okay. Hang on. Maybe I did my dimensions wrong. Okay.
I
So
think
we
I
have,
did it wrong.
all right. So we have, wait, let's go back up. All right. So for this
Jeremy,
closet,
what'd you get, buddy?
I'm still trying to work it out. I'm a little lost.
okay. So, all right. So the dimensions on this closet here, right, are going to be 3/4 by 1/4, right?
That's where I messed up at. I didn't see the 3/4. I divided
Oh,
1/4
okay.
by 2.
Okay. And then this one is 1/4 by 1/2 on there.
There's 1. Let's see.
Did I do it right? Did anybody get the same answer I did?
Yes.
Do you mind to scroll back up really quickly
Mhm.
so I can put it into my calculator?
Yeah.
Thank you.
Mm-hmm.
Yeah, I got the same thing.
Okay. Okay. All right, so the next thing, it wants us to compare the bathrooms. Wants to know which one has the largest bathroom. All right, so we're looking at this one versus this one. No, that's a bedroom. Hang on, I did that wrong. The bathroom is there, here. Oh, and I messed up my. Okay, so now let's do the same thing with the bathrooms. I'll let you guys work that and then see if we get the same thing. Okay, so. Oh, we didn't. Okay, we'll scale it on this one. We didn't use they have different scale factors. So we gotta go back and make an adjustment on the previous problem, but go ahead and get our values.
Now we're trying to find the area for a
Yes.
bathroom.
Uh-huh, area for the bathroom, for each bathroom. Okay. Okay, let me scroll down here a minute. So on this one, so for the suburb, did you get 0.5?
Yes.
Okay, and then the city, I
Point
got,
375.
yeah, 0.375. Okay, now here's what we forgot to do the last time. To actually compare them, the scale factors are different. So to get the actual square footage, we've got to do like what we did before.
About a scale factor.
Yeah, our scale factor. So it's 12 on the suburban and 16 on the city. So this would be that times 12 squared would give us the actual square footage. And this times 16 squared will give us our actual square footage. So I'm getting 72 square foot there.
Which one did you get 72 for?
The suburb one. And then, oops. And then I'm getting 96 for the city one.
How did you do that? Did you just multiply straight across?
Yeah, I did 0.5
Oh, I did 5.
times 12 squared and then 0.375 times 16 squared.
Okay, I did 5 times, like 5 raised to the second instead of 0.5.
Okay. Okay. All right. So there we can make an actual comparison. And then we need to go back up because we should have done that with the closet space as well. So for the closet space, we would multiply the 0.4 by 12 squared to give us our actual. So 0.4 times 12 squared is 57.6. That would be square feet. And then for the suburb or the city one, we would do times 16 squared or to get it scaled. So 0.3125 times 16 squared. So that gives me 80 square feet. On there. Okay, let's see what's coming up here. Okay. All right, so let's go. Oh wait, a 1-year lease for the suburban apartment costs $750 per month. For the city, it's $925. Which offers the greater value in terms of cost per square foot? Okay, so let's go back up where we calculated the square footage. So we had 720 square feet for the suburban one and 768 for the city. All right, so oh shoot, I just forgot what that was, 720. All right, so 720 square feet versus 768, okay. 768 square feet. So this is our city, and this is the suburb. And so the suburban is $750 per month. So $750 divided by 720 square feet gives me a price of $1.04 per square feet for the suburb. And then my city one, it's $9.25 per 768 square feet, which would be 25 divided by 768. 1.2, so $1.20 per square foot. Okay, so let me look at the homework and see if there's anything that they don't give you the dimensions. I think it gives you, wait, where was the, oh, my page is out of order. Okay. Okay, 1/2 inch corresponds to 6 feet. Okay, that one I think I need to give you the measurements of it. Okay, so, all right, so this is 1 inch by 1 inch. This is 3/4 by 1 1/4.
We're doing our homework now, correct?
Yeah, yeah, this is the ones where it tells you to measure it, but I don't need you to measure it. I mean,
Okay.
yeah, we'd all get this. So those are the actual measurements. And then, let's see this one.
Can you go back up to that for just a second?
Yeah,
Yes, still need to get that one.
okay.
So I got that part written down.
Okay. All right. And then, okay, so this one, store 1 is 1 7/16. It's going from there to there. By here to here is 1 13/16. Those are in inches. And then store 2 is 1 3/16 from there to there. And then this here is 1 13/16 inches. Okay. All right. So for the homework, all right, just do 1, 2, and 3. 2.
Okay.
Yeah. And the problem set, just do 1 through 3. So,
And that will be our homework.
and that's your homework. Uh-huh.
Is it right if I okay, I'm not gonna do this. I did not make enough room for this. Oh, I got it. Is it right if I take a picture of the one I sent you in that email, except have the homework for today under those 5 problems that we did yesterday?
Yeah. Yeah, that's fine. Okay.
Mm-hmm.
All right. Okay. So tomorrow we'll go over the answers to the homework and then proceed on with the next lesson.
All right.
Okay,
Mr.
wait.
Billy?
Yes.
So what problems are we having to do for homework again?
In that
doing
problem
1,
set, 1, 2, and 3.
2, and 3.
Okay. And
All
then,
right.
so then we'll have all the way up to day 4 done, correct?
Yes. If you sent me the other stuff already, then yes, you'll be all the way through day 4.
I haven't sent yesterday's, but the other 2
Okay.
days I did send. From
Sounds
last
good.
week. All right. Thank you.
Okay. I'll see you guys tomorrow then.
You have a good day, Mr. Billy.
You too.
Thank you.
So y'all.